Engineering students explained systems engineering in one word. Professor Siyuan then decoded their mind map.
Systems engineering is a multidisciplinary subject that brings everything together in modern days, which is a very important field that allows us to manage complexity. So this word is very important here, trying to address the complexity of modern products. And systems engineering is that formalized discipline that allows us to achieve that. In these days, we're using model-based systems engineering as a new approach, with models sitting in the center as the most important artifact to deliver systems engineering and manage complexity that we see. And as you can see, we have highlighted the word aerospace, defense, and the automobile, and these industries are shifting into using model-based systems engineering as we speak. And it's important that we see today Mbse is moving forward as well, with digital technologies evolving, such as artificial intelligence. We're covering a more broader spectrum of systems lifecycle. Traditionally, it's just requirements architecture, but we see more and more practice going beyond requirements architecture to include detailed designs, implementation, and testing, verification, validation, and maintenance through life, etc. And this really ties into product development, because we want to see how Mbse is really applied to a broad range of activities that covers the entire lifecycle activities. And that's what we're trying to achieve in an educational setting, trying to show our students that we can use tools and Mbse as a methodology to tackle the complexities that we see in different sectors using digital technologies such as digital twin, and to really, at the end of the day, to deliver a product, and not just any product, but a product that continues to evolve itself, that will continuously innovate. In order to do systems engineering, it is very important that we focus on system thinking, because that's the bit which distinguishes the kind of normal engineer to looking at systems, complex systems. So system thinking is what drives us, what guides us to develop products with this holistic idea of what systems need to do, the interactions between the elements within the systems themselves, but also with elements outside of the systems, especially when systems becomes very large, very difficult to manage. The boundaries between systems can be blurred, and as such we need a system thinking back in our mind, and trying to allow us to see the interactions between elements and with elements outside of the systems within the environment, and therefore coming back to, again, managing the complexity, using the right tools, using the right methodologies, and finally delivering our product. As an example, in the systems architecture module, we teach students the two languages, Unified Modern Language and Systems Modern Language. And as students learn these languages and the approaches and how to architect, they will be using CATIA Magic to model stuff as we go. And in the afternoon sessions, they actually apply what they have learned in the mornings into the case studies. So we have students basically forming in a group and looking at particular case study that we have given to them, as if we are the customers, and the students as the engineers, and the engineers will develop a particular product, the architecture of the product against the requirements that the customers have given to them, and using CATIA Magic and the methodologies that we have delivered to them in the margin. Eventually, by the end of the day, we hope we can reduce the complexity or even tackle the complexity, so that maybe in 50 years, 100 years, when we look back, the aircraft is no longer a complex systems anymore. And what really truly is complex, perhaps, is a shuttle space that allows us to travel throughout the universe.